Welcome everyone to the May meeting for 2023, the Mornington Peninsula Astronomical Society, and welcome any newish members here tonight. And we'll begin with a couple of things. Hopefully you can resolve them here. We'll begin with the top left, with the Artemis crew was announced last month, and that's the second mission to the moon. They'll basically go the same route as the first unmanned mission did, and hopefully the rocket, when it does go, which is due for I think November next year earliest, will go without a hitch as they slowly make their way back to the moon. Also late in April, as you see the top right hand one there from Jamie, he took a video that he posted online of the aurora that he took from down Tooradin Way, and you can see the beams of the aurora there down towards the south. There's the Milky Way, a couple of the large Magellanic Clouds there and there, and an aeroplane by the looks of it going by in that image. So very good on that one. What was that taken with, Jamie? Was it a DSLR or a phone? A DSLR, yeah. And that was on the 24th of April. Now, since we last met, a couple of companies have gone belly up. First one, I think, was Jenny Craig, went belly up. And so did Richard Branson's Virgin Orbit company, went belly up as well. They had a failed launch in Cornwall, and that's why I'm showing this upside down. When they launched the rocket with a couple of satellites on board, including a US, I think, defence satellite and a UK defence satellite and other things, it didn't quite make it, and they were completely destroyed, and they weren't very happy, and so consequently the company's gone into liquidation. Now I believe there are 20 or 30 potential buyers for it vying for the bits and pieces at the moment. So it may yet be resurrected from the dead. And of course, aside from Richard Branson, we have Elon Musk's one that you would have seen around the time of our meeting last month, or just after, when they finally got it up off the ground. This is the view from behind of each of the rockets, which are sort of strapped together, and sort of a technique that the Soviets developed for their rockets. And as you can see, that not all of them have lit up. So there's a couple missing there, a couple there, a couple there, a couple there. It's designed of those rockets that it can withstand, I think, a maximum of 7 out of action. And I think in that image there, you can actually count 8 of them are out of action. So it wasn't going to get up into orbit. So what they did is, over in this video here, they pushed the big red button, and the self-destruct mechanism blew the thing to pieces. It also did a lot of damage on the ground, actually from the liftoff itself. It left a great big crater in the launch pad because of the cooling system was inadequate to actually take the exhaust, so it pretty much destroyed their launch pad. And now the authorities in the USA, I think, are questioning whether there's going to be another one, because it caused a lot of damage in the surrounding houses as well. Structural damage and windows blowing in and things like that. So it wasn't too popular with the Texan locals nearby. So tonight we'll, as usual, go through the events, past and coming up. Then we'll put Trevor on first as a speaker, talking about sailing into darkness, all about the Ningaloo Eclipse that he went on recently. And the picture on the right-hand side is a bit of artificial intelligence from the DALL-E program. Came up, and this was its interpretation of the Ningaloo Eclipse. If you actually type that in, and you can see it's put a whale shark down the bottom there, so it's probably got that fairly accurately. And that thing is meant to be a cruise ship. Now the size of the bow wave suggested it's doing about 40 or 50 knots to me, which is probably a bit more than a cruise ship can do at a flat chat. And it tends to lose a bit of the detail towards the back of the ship. And as for the eclipse, well, it's got the sun. It's interpreted that as the sun, but not even a partial eclipse shown there on its interpretation. After Trevor, we'll go into Sky for the Month from Mark. There's not going to be an Astro Mo Pho tonight because Chris is up at Parks at the moment, and obviously that will resume next month instead. And then after that we'll have a bit of a coronation cake that Ros has kindly baked, and I'll explain a little bit more about that afterwards. Then after we've had the tea break, there's a few royal themed things to add on there. Incidentally, that's why it's purple, because purple's a very royal colour, because historically it was the most difficult colour to actually get from nature, and it was only when the chemist Perkins came up with Mauvine, I think in the 1800s, that it became accessible to the population. Up to that point, the only ones who could afford anything made of purple were those who were incredibly wealthy. We'll look at all about the Royal Observatory at Greenwich. I've been there 3 or 4 times over the years, and this is about like a 10-minute summary taking you through the astronomical aspects of inside the Greenwich Observatory. The Greenwich Observatory was actually set up by King Charles II. So in other words, the Charles before this one, and it was in response to a successful eclipse expedition that he had sponsored beforehand. It was such a successful one, I think it was in Germany they were sent to for the eclipse, that he then sponsored the Royal Observatory, actually located at a derelict castle at the time. So they actually repurposed it. Then after that we'll look at the throne and look at the ejection seats and all the ejection mechanisms that have been used for spacecraft over the years, and that's a good 10-15 minutes summary. And then at the end, because we've had an aurora during the month, we'll give a basic explanation of what an aurora is and how to actually see one yourself, given by the Bureau of Meteorology, because these days the Bureau of Meteorology actually runs the Space Weather Service for Australia. And then at the end we'll close again with a royal theme with something by Queen, all about string theory. Okay, so recent events since we met. The picture shown there was one taken down at Buchan a couple of weeks back, and shows Nerida and Guido there, and members of the LVAS and Astronomical Society as well. They got together for quite a successful viewing night. Long way to go, mind you, for 86 people. But nevertheless, it was a good chance for the societies to get together, and in fact over the coming months we may see visits from other societies here. So we've got a couple, I think, in the pipeline already wanting to come up here, and indeed we may have a field trip out to one of theirs as well, depending on what other things we're doing. 22nd of April, Cosmology Group met here at the Briars on the Saturday. Committee meeting went over the inter-society visits and also talking about Vastrock later on in the year. Then we had 3 school nights in a row. All were pretty cloudy except for the second one at Camp Mannion, which wasn't too bad, at about 25% cloud, and they went away very happy as a result of that one. And the public night here on the night after, so you notice there's 4 nights in a row we had talks going. The public night was completely clouded out here at the observatory, so we might see some of those reappear at the dune for the telescope part. And the Cosmology Group met here again on the 13th of May. Now, coming up soon, we've got, aside from the Working Bee this weekend and the committee meeting, we've got the next Scout Cubs and Guides night coming up on the 26th of May, so Friday week. And we know we're going to have at least 20 cubs and probably 10 cub masters as well, or group leaders to that one, so that one's definitely going ahead. Those Scub Scouts and Guides nights we would normally cancel if we don't have any bookings, you know, about 1 or 2 days out, and they're the only viewing nights we ever cancel. All others always go ahead, regardless. The public night, Trevor gave a talk, Trevor's going to be giving a talk, which I think is probably going to be something around the eclipse, I would think. Probably redoing tonight's one, yep. And then on to the MPAS monthly meeting next month, and hopefully we'll get the people who've gone up to New South Wales at the moment give that talk based on their experiences with astrophotography up there and whatever else they do at the South Pacific Star Party. So I think they're currently up around the Parkes Radio Telescope at the moment. And just a reminder, later on in the year, September, we've got the astrophotography workshop. And I don't think bookings are open for that yet, but it won't be long before they get opened up. Telescope Learning Day, we have 2 of those a year, and they're open to the members of the public as well as members of the society. Members of the society get first go at it, but when the bookings for that open, then you'll be informed by email. And at this stage, 25th of November is the VASTROC, or Victorian Astronomy Convention, which would be here at the Briars, and that will be a Saturday in November. The Saturday before that, or the Sunday before that, we'll actually be at Bentley for the Bentley Street Festival, so it's going to be quite a busy November. Now, tonight's feature. I believe this picture here of Trevor was that actually on one of the cruise ships?
Yes,
it was. Ah, okay. So I did.
There's an Effie in the background, so it's probably a princess.
Aha, yeah. Mind you, we've never seen you in a suit and tie for one of our talks, so and it is still not going to happen by the looks of it. Trevor, for those of you who've been in the society a while, has been talking at the public nights for more than a decade now, and he's got a range of paraphernalia that he brings along that has been built over the years, because it takes a long time to put together a presentation with some detail. And he's a very popular speaker, and he speaks on a lot of the cruise ships, although I don't think he spoke on the cruise ship tonight.
No, I didn't.
No. And with that, I think I will hand over the microphone.
I'll be talking about the eclipse of the 20th of April. I was actually over there, so I saw the whole 100% eclipse, which is actually the first one I've ever seen. And I'll talk a little bit towards the end about any upcoming ones and plans that you might want to make for some field trips, particularly for MPAS in the next few years. There's quite a few coming up. Okay, so I'll just give a brief description about eclipses, because most of the people here know exactly how they happen and why they happen. But there's an interesting thing about the sun and the moon, and one is, if you look at these numbers, you'll see that the moon and the sun are actually roughly 386 times difference, in distance. So the sun is 386 times further away than what the moon is. And if we look at the size, we see that the moon and sun are a similar ratio in size. So whilst the sun is 386 times further away, the sun is also 397 times bigger. It varies, of course, because the distance the moon is away from the Earth varies in the orbit, and the distance to the sun varies slightly, not a lot. But they're within a par, and at times they're exactly the same, and sometimes just the moon is just slightly smaller. So the result of that is that, as seen from the Earth, the two appear to be the same size, which of course, when the moon passes directly in front of the Earth, if it's exactly the same size, it will blot the whole of the sun out, making a total eclipse. Now, unfortunately, this isn't what I saw, because I left my glasses in the car at Tullamarine Airport. So I was watching the eclipse, and it's like, oh yes, it's a little bit blurry. So it wasn't as good as what it should have been for me. So, and I'll go into some of the detail too, why it actually didn't turn out to be such a great event for myself as what I was hoping. Not just because I didn't have the glasses with me. So at this particular time, there will be an area where the moon will completely block the sun. if you're outside this area, you'll see a partial eclipse. Melbourne was in that area where you saw a partial eclipse. And much further away, you didn't see any eclipse at all. You wouldn't have seen anything. Now, these are some recent and upcoming eclipses. The last eclipse in Melbourne was the 23rd of October 1976, which is quite a long time ago. Now, there's also a few others here that I don't know if there'll be many people here who'll make it to 2093. Some might make it to 2038, but there are some coming up, not just the ones just nearby, you know, in the next couple of years, but in Australia there are others coming as well. But of course, when's the next eclipse in Melbourne? The last one was 1976. So when's the next total eclipse if you live here, so you don't have to go anywhere other than walk outside? It'll be Tuesday, the 4th of April. It's around about 5 o'clock, so the sun will be a little bit low, in the year 2220. So eclipses are not, they're one of those things people say is a once in a lifetime event. It's not, because they happen almost every single year. As you can see here, they happen quite regularly. There's just a gap in 2025. So they're not a once in a lifetime event, but you have to travel. If you don't travel, if you miss one, you probably won't see another one. Although these ones here, if you live in Victoria, there are some coming up. There hasn't been any for quite a long time. Whoops. So this was the most recent eclipse. It was, believe it or not, was almost a month ago now. It'll be 4 weeks ago. Tomorrow was on the Thursday. Now this was comes off the coast of Australia and goes up into Indonesia. Now I did a bit of a search because my wife and I do a lot of cruises, and we thought, would there be a cruise that's going that way? And there was only one large cruise ship in that area, which is a P&O ship, the Pacific Explorer, was the only one that was destined to get to the eclipse. There were some smaller ships which we saw when we were there, but those ships, you're talking maybe $10,000 or something per person, very, very expensive ships as they come from Darwin and come down the coast, or I believe some of the local boats came out onto the water for the eclipse as well that were in that area. Because when you see the path over Australia, very little of the land was in the right spot. And there was at least 2, I don't know if there's any more members that actually travelled there. I know there was Greg, who's still on his way back, that actually went to that tiny little bit of Australia. You can see this is the path of totality, and there's this tiny little bit of land that sticks out just on the side there. That's the only place. So even if you lived along here, you would only see a partial eclipse. So a lot of the towns around here, the ports, had cruise ships that went out to the line of totality on the water so that you could see it without having to go to Exmouth, which was apparently the closest accommodation you could get was something like 3 hours drive. Everything local was booked out. Exmouth is not known for having huge hotels or accommodation anyway. So we decided that we would book ourselves on this particular ship. So we left for Fremantle a number of days beforehand, because we figured we'd have a little bit of a holiday rather than just get on the ship and go to the eclipse. So we landed in Fremantle a few days beforehand. We were actually fortunate enough when we were there, we met some stars of some television commercials which you may recognise. Now, we managed to catch these little guys between shoots. Some of them weren't particularly interested. They didn't want to give any autographs or anything like that. Walked away. Some were really wrapped. They sleep in the weirdest position. You see them everywhere with their heads stuck between their legs. I don't know, it looks like they're sort of sniffing their own bottom or something, I don't know. But that's how they sleep. All right, so the quokkas are a little bit weird, I guess. And the seagulls, I saw all these lined up. I think they were just waiting for a chip, perhaps. There was a wedding, and I saw all these seagulls all lined up, all sitting there, I think, waiting to swoop and grab something when they could. So then the morning of our cruise, the ship came in. It didn't arrive until lunchtime because the previous cruise didn't finish in Fremantle till fairly late. Usually cruise ships will come in around about 8 o'clock in the morning, and so they disembark, but this came in at midday, so boarding on the cruise was actually around about 9 or 10 o'clock at night, so it was quite a late departure. But there were no ports or anything. All we had to do was sail to where the eclipse was. Now, the Astronomical Society of Australia actually provided a number of their members, astronomers, doctors, professors, etc., of astronomy and similar subjects. And they gave a series of talks. Sometimes there were 3 or 4 talks on at the same day. There were so many that some of them I just couldn't be bothered going to because I couldn't fit in when to have lunch. There was so much to hear and so much to see. So this is a list of the subjects that they covered and the names of I didn't put down whether a professor or a doctor or whatever because some wouldn't have fitted on the line, so I couldn't fit all, so I didn't put any down. So these were the subjects. Some of these people you may have heard about before, some you may not have. So I've just taken a few snippets just of a couple of the talks just to get an idea of how the talks went. So this is on the very first one.
When the sun makes its path across our sky, its path is called the ecliptic, and we can see it here in this sort of yellow line that cuts across the screen. And so when we look for the planets and like our moon, when we look for them at night, they're going to be travelling approximately along that same path that the sun took during the day.
Right, so there were a number of subjects now. This is Kelly Beattie, who used to be one of the editors for Sky and Telescope, American Sky and Telescope. He gave a number of talks as well. Now this is one that he gave, which was basically a guide to the eclipse. As you can see, the room was packed, absolutely packed. This was well before he even started. So there was maybe another 10 minutes for people to come in, and by the time he finished, all across the back was standing room only. I think this theatre holds around about 400 people. There's about 2,000 passengers on the ship. So there's a lot that weren't interested. We actually met some passengers who didn't even know there was an eclipse. They just booked the cruise because they wanted to have a cruise that goes to nowhere without knowing anything about the eclipse whatsoever. And there were other people that actually travelled all the way from the other side of the world to get on this ship. So from both extremes. So this is his talk about what totality is like.
Is a picture of a total solar eclipse at mid-totality, when the moon has completely covered the sun, and that
Sorry about the volume.
See in the sky, where the sun had been shining just an hour before, is a black bullet hole in the sky, surrounded by an electric white wreath that doesn't quite look this structured because this has been processed to show a lot of detail. And all around you, it's twilight, except along the horizons where outside the shadow of the moon, it's still daylight.
That was interesting with this eclipse. Normally when you would go to an eclipse, you expect it to be totally dark. It never got totally dark at all, as you will see when you see some of the video that I shot. Now this is a map of where we would be located. So this is the little bit of Australia that sticks out where you can actually stand on something. That's the only place in the whole country you could stand on. So we were to be anchored just off the shore here, virtually right on the very centre line. He also gave a timetable of when it started and when it finished. So like a total eclipse of the moon, it takes a very, very long time. But unlike a total eclipse of the moon, blink and you'll miss the key thing. Total eclipse of the moon, if it's red, come out half an hour later, it's still red. Total eclipse of the sun, come out a minute later, it's all over. You're finished. You missed it. So you've got to make sure that you're outside right between 11:30 and 11:31. We had actually about 58 seconds to see it. This is another talk about what the corona
2
is.
million degrees Celsius, that's almost 4 million degrees Fahrenheit. And it glows with its own light, both reflected light from the sun's disk, and it gives off some of its own light. It's 1/1,000,000th as bright as the sun. So no wonder we never see it. But during a total solar eclipse, we can. And it's not just an amorphous blob, it's got structure to it. Because this superheated gas is being controlled by magnetic field lines of the sun, and it gives it shape and tendrils and wreaths and all kinds of rays streaking out. So this is all stuff you can see with your eye.
I didn't see any of that because I didn't have my glasses. It was all blur to me.
At what point did you realise that you'd forgotten your glasses?
Not long after I got on the ship, which was no point because we were in Fremantle and they're in Tullamarine Airport. So, yeah. This is Jonty Horner. You may have seen him. He was recently on the television about the Aquarids or something, meteor shower or something like that. He was on Channel 2 or something anyway. But you'll recognise his voice and his accent.
They don't have dash cams to, as in this case, record spectacular celestial phenomena, but they have them to prove that when they have an accident, it was the other guy's fault. But occasionally you see something like this. The next thing I learned is that Russian drivers are crazy because they just carry on. Nothing to see here. But I'll talk you through what actually happened here. I would have been turning around then.
Yeah, it was interesting because anyone that knows my talks, I often give my talk on meteorites, and I use this video too. I use, in fact, a lot of the talks, I use exactly the same pictures as what I use in exactly the same subjects. So it was interesting that at least other people see the images that I've been able to catch are also useful. Now, there was another question and answer session that they did with all the astronomers were all on the podium in the theatre, and people could ask any question they wanted. So I put this in because astronomy is not very funny. This actually turned out by pure luck to be quite funny. Hopefully you can hear what they say.
So to form the heavy elements, we need, we know that heavy elements are formed in a process called rapid process nucleosynthesis. And at the beginning, in the Big Bang, we don't know obviously what the conditions were, but the last information we have about the Big Bang. So,
What's the Big Bang? It's the Big Bang.
I think we now have an extra microphone. So this is how new microphones blow.
It was quite sort of random timing that just as they said the word Big Bang, one of the guys dropped the microphone on the ground and everyone cracked up. So the evening before the eclipse was beautiful, clear skies, lovely sunset. I was hoping for a green flash. Didn't happen. It looked promising. There was a lot of people along the side of the ship were waiting to see if there's a green flash because it's got what they call an omega sunset where it sort of sticks out at the bottom, but no, the sun just went down. And there's no land because there's no land until you get to Africa from this particular point. So this is the morning of the eclipse. Now people had been setting up telescopes for the previous 2 or 3 days on the ship to get set up, work out their exposures for the sun, work out where they wanted to set up their telescopes, tripods and all that stuff. So this was the morning of the eclipse. There were tripods everywhere. The whole ship was covered in tripods and SLRs and various types of telescopes with solar filters. There were hydrogen alpha, there were white light, there was everything. So we were prepared, even our little towel animal had his little glasses on. So people were setting up from early in the morning. You can see here the length of the shadow. So this was quite early. This is at the front of the ship. So these are right out at the very front. Now there's several criteria that needed to be taken into account for being on a ship that you wouldn't necessarily have to care about if you were set up on land, because the ship is very different. And fortunately, the group of people from Sky and Telescope, of which there was maybe 3 or 4, Fred Espenack was there as well, and the guy from Sky and Telescope, and they had meetings with the captain to work out where to be and various things that they needed to do to make sure that this would all work. So as I say, there's criteria that's different, that until someone points it out, you'll think, actually, yes, they would need to consider this. Firstly, the ship needs to be still, right? They actually, where they anchored off the side of the land, they dropped anchor, so they didn't need to have their engines running, so there was very little shudder. All they needed was just their side thrusters just to keep us stable. So they dropped the anchors and turned the main engines off. They only had minimal power, just enough to keep the generators running so that there was light inside the ship. You need to orient the ship so that the smoke doesn't drift across the sun, because the corona would be a lot more difficult to see if smoke is drifting past it. So you have to orient the ship so that the prevailing wind blows the smoke away from most of the ship, not to send it down the length of the ship, but just off to one side to keep that to a minimum. So smoke wasn't a problem. There was smoke coming out of the smokestack, but it just drifted to the side. It didn't come along the length of the ship. So they had the orientation right. Now the ship needs to not turn. If you've got a ship and you drop an anchor, anyone that's been on a cruise and you look out at some time where the ship has been anchored, you'll find that over a period of time it turns. Now if you've set up on the deck of the ship with your tripod and there's the sun, and then the ship moves, you would have to constantly move the tripod back. So they had to ensure that the ship did not turn. They only have one anchor at the front, they don't have one at the back to hold it steady. So they only had the side thrusters to keep it stable. And they actually did a very good job. The orientation of the sun didn't appear to change at all. The only changes in the shadow was caused by the fact that the sun moved. So the people that had their tripods set up didn't have to adjust, not by any major amount that I was aware of anyway. There's also limited spaces to set up. There are a lot of large deck chairs. You imagine how much space a deck chair takes up. You could get 6 or 7 people to stand in that area. So what they actually did, they took about half of the deck chairs and put them away. So you couldn't get people taking up valuable space. People were worried that there would be 2,000 people on the ship. Normally when you're on a cruise, not everyone will be outside. But in this case, the vast majority of people would be outside. How much room would you have? And you'll see that in the pictures, there is actually a surprising amount of room. Now, one interesting thing that someone mentioned, probably about 20 minutes or so before it went total, they went inside the ship and down to where the coffee shop is to get a coffee. And they said there were 2 people sitting there with their back to the window, reading a book just before the total eclipse happened. I'm sure they complained for about 58 seconds that someone has turned the lights out because they can't read their book anymore. But there were 2 people that were so uninterested in something like this, they would rather read a book for 58 seconds than to see a total eclipse of the sun. I couldn't believe it when they said that they couldn't believe it, that they saw 2 people down in the coffee shop with their back against the window. It's not even as if they would see it went dark outside. They weren't even facing in that direction. So some people just take a lot to get excited. Now these are some pictures of people on the beach. We were further out. I don't exactly know where this beach was located compared to us, but this will be on that tiny little bit of land somewhere. Greg Walton is around somewhere, not in amongst all this crowd, I imagine. But there were lots and lots of people standing on the beach here, watching the various stages as it approached totality. You can see here, this is obviously at totality because they don't have their glasses on. When it's actual totality, you can look at the sun with binoculars, normal binoculars. For me, it was still a bit fuzzy because, again, I didn't have my glasses. So that's not going to happen next time. Right, so this is obviously at totality, but it didn't go completely dark. In fact, nothing like it. This is a photo that Nerida Landcake took. This is the maximum that you got in Melbourne. 11%. You wouldn't have noticed that it even got much duller than normal. It needs to get much, much more than 11% before you notice anything. Even on the ship, as it was progressing, it didn't appear to make any difference, and you'd look up with your glasses and it's like half the sun's gone and it really doesn't look any different. Everyone was given 2 double-sided printouts of information of how to view the eclipse, some of the various things you can do. You can, pinhole projection and all that sort of stuff, how to view it without any particular equipment or eye protection. Also, some of the things that you can do, they're crossing their hands to make little crescents. I'll talk about that in a minute. So everyone got a printout of this. We also got particular special glasses from Sky and Telescope. So everyone, all the passengers, a lot of the crew didn't get anything. But all the passengers were given these, and they said the good thing about having a lanyard is you can put this around your neck and you can view the sun, and when it's total, just let go. Which actually is quite sensible, because if you've got glasses and you let them go, then someone will stand on them or they'll blow over the side of the ship or something. So they came in very handy. But we brought our own glasses, so I got these from Bintel, a whole $3.50 beforehand. But of course with these, when it goes total, you've got to take your hands away, but if you want to take a picture or something with your camera and you've got these, where are you going to put them? So we actually ended up using the ones that were provided with the lanyard most of the time. I also bought, before we went, a pair of solar binoculars. So these are special binoculars that you can view the sun, 8 magnification, $150 at Bintel, so you can't really argue with the price. And you can hold these and look at the sun at any time. So there was some sunspots on the sun, which I couldn't see because I didn't have glasses, but I could easily see them in these, and you could see the moon moving across, slowly wiping those sunspots out through these. And these are very popular because you could sort of say to someone, you want to have a look, because you get a much better view at 8 times magnification than just with the naked eye, even if you've got your glasses on. So these proved very popular as well. There were some people, this group of people, this was eclipse number 19 something, so they've seen, probably for the last 20 years, they've obviously travelled everywhere. They saw the great American eclipse of 2017, and they just travelled. They're a little bit sort of weird, let me say. Actually a little bit more weird than what they look. Yeah. So they'd been to many, many eclipses. This is a couple of the crew. They'd never seen an eclipse in their life. So they thought that they were so lucky to be rostered on a ship that's going to see an eclipse that they've never seen before, and they're getting paid to be here. So they're part of the entertainment crew as well. So as the sun nears totality, it begins to get a little bit dull. And the light gets unusual because the sun is like an extended light source. It's not like a normal star with a point. It's actually extended. So if you cast a shadow, if you were to look at it very carefully, you'll see it's not clearly defined because it's like the shadow of the Earth. It has the main umbra at the centre, but there's a penumbra around the edge of all the shadows you cast because the sun is not a point source. But as the sun gets narrower, it gets smaller and smaller and becomes more like a point source, and the light becomes really weird. Shadows get incredibly sharp, razor sharp. Even without glasses, the shadows just became so sharp. And the light just started to get, it was hard to describe, but the light was weird. You could still see, it was still almost bright daylight, and this is only maybe 10-15 minutes before totality, so it's still quite bright, but the light is really weird. If you're on land and there's birds, the birds start tweeting and they head into the trees. We didn't have any birds, not even seagulls or anything, so we didn't see any of that sort of phenomena or hear anything. But the one thing that a lot of people said is the light is really weird. They couldn't describe it. It's just unusual, perhaps because the shadows are so sharp. Now, as it gets close to totality, you can cross your fingers like this and you get all these. I didn't really do it very well here, but hopefully you can see these little crescents of the partially eclipsed sun. Some people actually brought a colander from the kitchen with them that's got hundreds of little holes, and they held it up and you got hundreds of little sort of solar eclipse images. Now, another phenomena is what they call shadow waves or shadow bands. I tried to video this and it didn't really come out. Now, as the sun gets more and more narrow, the turbulence in the atmosphere actually makes this sort of like a walking shadow appear on the ground. Best seen if you've got a white area, but the deck of the ship is not particularly white. This is an artificial sort of a greeny colour like grass. But with the naked eye you could see these shadow ripples moving across the deck of the ship. You can only sort of just, if you look really carefully, you could just sort of see them. My wife shot this, so she only did about 10 seconds. The bit I shot, nothing turned out, so I deleted that file. Now, as totality draws closer, so this is only maybe 5 minutes, 10 minutes before total, you can see it's still quite bright, even though most of the sun is gone. So people are getting ready, they're checking their exposures, all the cameras. So you can see, even though the area we were at, which was at the back of the ship, there was a lot of people, but it wasn't too crowded. There was plenty of room for you to stand. Now this is 2 minutes before the eclipse. So the sun is up here, and this is just a quick video that I shot of people. So it's only 2 minutes to go, so most of the sun is gone. It's still quite light, it's beginning to get dull. So people are standing around, occasionally looking up at the sun. Again with eye protection. Photos on mobile phones don't generally work.
2 minutes until totality.
So that was the guy from Sky and Telescope. 2 minutes to go. Now this is at totality. This is what it looked like. It's not pitch black at all, not even close. Very, very dull, but not totally black.
Oh my God. Look at this.
So that's totality. There should be black in the middle. The camera doesn't pick it up very well.
There's Venus
That's Venus
and
there.
Jupiter.
And Jupiter's right up near the sun.
It's like
You could see, very close to the sun, broad daylight. The two planets became blatantly obvious even before totality. You could see Jupiter.
Yeah, you can see a little bit just on the edge.
Can we look at it now?
Now, unfortunately, I was busy videoing all these people, what they were looking at. And, oh, this is great, fantastic. They're all yelling. And then I thought, why don't I look at it? I'm spending, of the 58 seconds, I spent nearly half of it getting the expressions of people yelling and screaming and clapping, and I'm not even looking at it. So then I glanced up, and I can still remember, even though it was blurry, I can remember seeing the crimson, an almost indescribably bright crimson, which are the prominences and that from around the edge of the sun, just as the moon blots it off. And I could see a little bit of white, which was the corona. And then I thought, shit, there's the sun. And it popped out, and I had to instantly move my head away. So of the 58 seconds, I saw about 15 out of focus. But I got people cheering and yelling. So I know next time I can still video like this, but actually look up at it while you're doing it. So I sort of got ripped off. My wife saw far more than what I did. She had, it was funny, she had this thing looking at it, and she said, I can't see it, where'd it go? Where'd it go? She couldn't see anything because, of course, it was total and you need to remove this. And she said, can I put it down? I said, yeah. So she put it down, and then she was able to see it while I'm videoing everyone, not seeing anything, even telling my wife, yes, you can have a look, because I'm not. Right, so these are a couple of captures that I took off that video because it's so quick. So you can see towards the horizon, it's not dark at all, it's actually quite bright because the width of the shadow wasn't particularly large. It's only like, I think it was less than 100 kilometres wide. So the horizon was more than 50 kilometres away, so it was outside the shadow, so it was quite well lit. So it's almost like a twilight out on the edge of the shadow. There's the sun, there's the planet Jupiter. It would have been interesting if you had a pair of binoculars. I wonder if you would have seen the moons. They're hard to say because the sky was quite dark but not black, not like night time, because it's such a narrow shadow. Sorry? Yeah, because you could see some other brighter stars, but if you had binoculars, I don't know whether that would be enough to be able to capture them, because there's probably, you might get down to third or fourth magnitude, which is not enough because they're about sixth. So, but maybe next time I'll take normal binoculars. Of course, if you're Irish, you would get out your solar binoculars and go, oh, can you see the moons of Jupiter? Yeah, no, I can't even see the sun. So I said, this would be a great practical joke. You could stand there and go, oh, look at that, oh, look, oh, the whales, look at them. And they have a look, and of course, it's pitch black. And you go, can't you see anything? What's wrong with your eyes? Yeah, so this, theoretically, this should be totally black with the corona around the outside. But as you can see, the camera can't even come close to capturing that. It's far too much contrast. It doesn't have a hope in hell. So you really need to have proper setup with a proper camera and lens and filters and everything, and be prepared more than what I was. And that's the planet Venus, again, quite easily visible. So Venus was there, the sun was up about there somewhere, a bit hard to see, but sort of just up on the roof somewhere. So relatively close, easily visible to the naked eye, even if you don't have glasses on. Now this is a time lapse that Greg Walton took. So this is greatly sped up. So when you were looking at the sun with those binoculars, you could see these sunspots quite clearly, all three of them. And progressively, each time you looked, 10, 15 minutes later, another one would be covered up. So he was set up somewhere on land with his setup. So these are a few pictures that I got off the internet because I don't have the equipment or the know-how to take pictures like this. So this is a little bit of the corona on the outside. You can see a prominence here and another one here. Now this is what I saw as a glimpse. I remember seeing this unbelievably bright crimson. It's just iridescently bright just off the edge of the sun as I happened to look up just before the sun actually popped out. So something you would never expect to see, because of course if you use a normal solar filter to view the sun, you won't see the crimson colour or anything like this, because you need to blot out the whole of the surface of the sun to see this bright colour. This is another one. Again, you can see the corona, the structure in the corona as the magnetic field lines give it some sort of shape. This is basically what I saw, but because it was taken through a camera, it's been rotated, so turn that about 90 degrees. That's what I saw when I looked away. The sun poked out and instantly it was so bright, within a fraction of a second I knew I had to look away, and then that was the end of the eclipse for me. Now the next eclipse that's coming up, 2024, it's almost the same time of the year, but it's off the coast of Mexico and North America. Now this particular one, you can see the path of the total eclipse. It comes in here. It actually starts further down in the Pacific Ocean, but comes into the coast of Mexico, across Mexico, some of the lower states of the US, up towards the Great Lakes, and then it exits on the far coast of Canada. This one is 4.5 minutes, so more than 4 times longer. And the width of the shadow is 198 kilometres versus less than half that for the one that was at Ningaloo. So I would imagine the horizon will get much, much darker. It will be much darker because the shadow is so much wider. Now the interesting thing is, this is a simulation of what you should see. You should see the eclipsed sun, the planet Mercury, Jupiter. If you've got binoculars, you may be able to see Uranus, Venus, Saturn and Mars. All of the naked eye planets will be visible at the eclipse next year, all within close proximity. And a comet, this is expected to be potentially magnitude 5. So if the sky is dark enough, even without binoculars, it may be barely visible because the sky will be much, much darker. Otherwise, with binoculars, it's probably reasonable that you might see a comet as well, so that you could potentially see 5 planets and a comet and the moon and the sun all at the same time if you've got a wide enough field. So many more things to look at, that one compared to the one that's just passed. Now this is a cloud prediction. As the path goes over the US, you'll see it starts in the Pacific Ocean, and as it gets nearer to the land, the percentage of cloud cover begins to drop. So right at the coast, it's potentially, statistically, 30% cloud at that time of year. So the best place is just off the coast of Mexico or just inland of Mexico. As you head across the US towards Texas and Arkansas, etc., the likelihood of cloud cover increases until you get out towards Canada, Newfoundland. Statistically, it's around 70 to 80% cloud cover at that time of the year. So the best place to be is right here towards the start, the coast of Mexico, or off the coast of Mexico, or just on the coast of Mexico. Now there's 4 cruise ships that are actually like the Pacific Explorer. There are 4 cruises specifically targeting this eclipse as part of the cruise. This one here is actually organised by Sky and Telescope, so those same people will be there. I guess Fred Espenak and all those will be on this particular ship. We can't go on this one because we have something planned. We can't leave Australia until like the 2nd of April or something. So we couldn't even make this anyway. We have other things. There's this one here, which is a bit earlier. We could make this, but because it goes all the way out to Hawaii, it's a very long cruise, so you're talking a lot of money. So much, much more expensive. But if you wanted to do a cruise, see Hawaii and see a total eclipse, it will also be off the coast of Mexico. The Discovery Princess was specifically targeting the eclipse as well down here. So it was quite a short itinerary. This ship is completely booked out. There is no room left. When Princess discovered that the Emerald Princess was almost in the right spot, they actually changed the itinerary of this cruise so that this one can also make the eclipse. So there will be 4 large cruise ships holding between 2,000 and 3,000 passengers just off the coast of Mexico to see this. So at the moment we're looking at booking on this. There's mainly internals, probably about 40 cabins left. Cost is about 3.6 to 3.8 for an internal, just to give you an idea, and then airfares to Los Angeles, because you actually got to fly into Los Angeles and come home from Fort Lauderdale. So the airfares are around about $3,000 if you want to get an idea how much it would cost to see this eclipse. But it's also a cruise holiday, if you like, in its own right, not just the eclipse off the side of the coast of Mexico. Now, following eclipses that are coming up a couple of years after that, as you'll see, there's nothing in 2025, unfortunately. This one in 2026 starts way up in the north in the Arctic, traverses across the Atlantic, and only really goes across virtually Spain. It only barely touches the border of Portugal. Sky and Telescope apparently are organising a tour to Spain, somewhere in here where they'll have their group, and it's like a bus tour. So they go to other places like observatories and things like that as well. So it's not just specifically for that. Duration, just over 2 minutes. The shadow though is nearly 300 kilometres wide, so I guess this one will be quite dark. 2027, if you've ever wanted to go to Egypt, this is probably the time to do it. Catch the pyramids. I don't know where the pyramids are on this map compared to the line of totality, but I suspect the pyramids are just outside. Yeah, that's what I thought. They're sort of up towards the delta up here. But of course, you could easily, I'm sure there'll be tours, Sky and Telescope is probably one of them, that will take you to Egypt and you can see the pyramids and the total eclipse. Otherwise, of course, there's all these other areas. You could go to Gibraltar. It goes right across the Rock of Gibraltar as well. So that's in 2027. This one is nearly 6.5 minutes. More than enough time even for me to realise, instead of videoing it, maybe I should look and I could catch at least 5.5 minutes of it rather than seconds. Right? It won't happen again, I can assure you. I will be much more aware. So that's 2027. And then of course, the big one for Australia is 2028. This will only be a partial eclipse in Melbourne, but it will go through Sydney at about 2 o'clock in the afternoon, comes in over the Northern Territory. So you can see it comes right over the side, all the way across central Australia and right through Sydney, 2 o'clock in the afternoon, 5 minutes and 10 seconds. So a reasonable amount of time, 230 kilometre width, so it should get fairly dark. The problem is Sydney at this particular time of the year, statistically is around 60% cloud. So the obvious place to go would be somewhere here where statistically it's unlikely to have much cloud at all. So I'm sure Greg Walton and others will be organising a trip, not so much to go to Sydney, but to somewhere along here I'm sure you can find information about what particular towns are situated here. I don't think it'll be a problem finding somewhere to set up and have so many people around you. I think the next person quite likely would be over the horizon, even if there's thousands of people viewing it. So this is in 2028. The big thing is that it goes right through the middle of Sydney, also the South Island as well, but I think that would probably be clouded out as well. But the best location is further inland from Sydney if you want to see it. It would make a perfect trip, MPAS little get-together. 2030, there's another one coming to Australia. Australia's getting lots of them. So 2030, just 2 years later, it starts right down in the Southern Ocean, comes across South Australia, almost eclipses Adelaide, 3 minutes 44, but unfortunately by the time it gets up towards here, the sun is almost set. So you won't get a very clear view. The best place to go would probably be somewhere around outback South Australia, I would imagine. Again, perfect trip for Greg Walton and friends. 2038, Boxing Day. So it's a public holiday, so even if you're still working, it's a holiday. If you look carefully at this map, it looks like virtually the whole of the Murray River is in totality. So essentially, if you go to anywhere on the Murray River in Victoria, Boxing Day 2038, the total eclipse is going to go right over the top of you. And by the length of the shadow that remains, sunset is obviously quite a long way away, so it's probably fairly high up in the sky. Only 2 minutes odd, 95 kilometres, so it'll be similar to the one that they had at Ningaloo. So it won't be really, really dark, but it'll get quite dull. But again, perfect opportunity. It doesn't take much to drive to the Murray River. It's only a few hours. So that would be, again, a perfect opportunity if you wanted to catch the 2038 eclipse. It's a few years away. Hopefully I'll at least make that one anyway. Some of us mightn't. Don't want to cast any aspersions on anyone in this room or anything like that, but some of us may not make to 2038, might even be me. Yes. So with these eclipses that are coming up, get ready. Work out what your plans are for the next few years, because we've got, what, 3 within a 10-year period. And we haven't had very many, probably Sejuna or something might have, oh, there's one up near Cairns that was a few years ago. We haven't had very many, but there are 3 within quite a short period of time. Yeah. Oh, thank you all. Now you can try getting yours back together again.
Questions?
Oh, if anyone's got any questions.
You might need to repeat them as well.
I might need to repeat them as well. Yeah. Yes. Anyone got any questions about it? Other than why did I not realise that I didn't have my glasses with me until we were like 3,000 kilometres. Even when we were in the plane, I didn't realise it. And then we landed and I go, oh, shit. Yes, Phil.
Did the ship sell any reader glasses? Fly readers?
No, my eyes, I'm short-sighted. They're long-sighted glasses. It would have only made it worse. Yeah, so I couldn't even borrow my wife's glasses, because the good thing is when we go out, she can read the specials and I can read the menu, and we don't need to have glasses with us because I can't see the specials, but I can read the menu. Yes.
I was going to say, I saw the 76 eclipse and I went up to Cathedral Ranges and sat on the cliff in the Cathedral Ranges. It got very dark.
Yeah.
Almost like night. And the cows got 3/4 of the way back to the shed.
Yeah, and then they turn around and go, gee, that was quick. Yeah, yeah. I experienced the 76. My uncle had organised a wedding in Colac on that very day. So we had to drive down for the wedding, and as we were coming back, my brother was driving along the Geelong Highway, and we got to the Little River turn-off, and prior to that we could hear the birds chirping and getting into the trees. And then we went under one of the overpasses, and it got dark, so he put the headlights on. And then it got light again, so he turned the headlights off. That was it. That was my experience in 1976, which doesn't really count. So that's why I say the first one was this one at Ningaloo, and we've just got to organise flights and stuff for this one in America, and then I'll book it. I'd say 90% chance we'll go to that one.
From memory, I thought that one went, certainly where I was very close to the maximum totality.
It did go really dark, I remember that.
I thought it lasted about 5 or 6 minutes.
Yeah, I can't recall.
It seemed quite a long time,
Yeah, I do recall that it got very dark to the point where it was night time, and because I wasn't driving, because I didn't have a licence, I wasn't that old. Yeah, that's all I can remember, that it got very dark, and it was for quite a while. Yeah.
There was a time-lapse shot that you showed where
Yeah, Greg's, yep.
How long did that take?
It was about maybe a couple of hours in total, the duration. 4 hours, right, yeah. So it's quite a fast time lapse, yes.
Comment about the Port Douglas one. Cruise ship did not make the spot when it was supposed to.
Tell Peter about it.
Are you on board with?
And
I was on board.
because that was the worry. That was P&O. We were on P&O.
It got to within 99.5% of the way there.
Yes, so you almost got a total eclipse.
When was it? It was
I don't know.
2012.
Was it?
Yeah.
Right,
I went to that one in the desert up in Canada.
right.
Yeah, that was pretty good. Yeah.
Yeah, that's what I was worried with the cruise, but I thought, I don't want to drive all that way, like as far as what Greg drove, or even fly to Fremantle and hire a car and drive up there. That's why we thought, oh, we'll take the cruise ship and take it as a sort of as a holiday. That's why we went across to Rottnest Island and stuff like that. Yep.
I was on the shore opposite your ship,
Yep.
and in the morning it was very windy. Did you notice that on the ship? The wind died down as we got
Right.
to totality, but
Yeah.
before that, it was quite
Yeah, no, I didn't notice any wind. It seemed to be quite
I've got a picture of the
smooth. Oh, have you?
I think it's yours.
Right, yeah. There was a small ship out there near us that had like a blue hull and white at the top, whereas we were pretty much fundamentally white. But it was fairly small. It was maybe 100 passengers or something like that. I think it was one of the Coral Seas cruise ships, which just do up around the north, and they're like $1,000 a day. For $1,000, I want a 1 week cruise. I don't want a day. Yeah.
Was there a contingency for the ship to move if it was cloudy, or wouldn't it?
It could have, yeah. But they had the predictions that it was going to be clear, and they'd worked out.
Trust predictions.
Yeah, as it turned out, it was probably the best day you could ever hope for. There was not a cloud in sight anywhere. The weather was perfect. Well, it was on the sea anyway. Yeah, it wasn't rocking or anything. The ship was quite stable. Yeah.
Recall who it was. There were some astronomers from somewhere in Australia had a plane on standby for the Port Douglas one to go inland if they had to.
Right, yeah. Yeah, because NASA does the same thing with some of theirs, because they're using information from the eclipses for
Well,
some
that's
other
what we
thing.
did for that eclipse. We thought being at the beach was good, but it was cloudy most mornings, so we drove inland.
But the clouds shifted just at the right time.
Yeah, well, it was perfectly clear when I got up, which was around about probably 7:30 or something. I went out on the deck and it was clear.
The day before it wasn't there.
Yeah, I know, it was perfect. Yes, it was unlike the viewing nights we have down here, where it's the exact opposite. That you have a beautiful Thursday and you'll even have a beautiful Friday, and then by dinner time the clouds come in, and then you get up Saturday morning and there's not a cloud in the sky and the PVN's over. Yes.
So we set up a couple of days before at Palm Cove.
Yep.
And there was this old timer. We would walk on the beach, and he said, "You know, mate, you're wasting your time. You see that cloud bank? That's there every morning."
Hmm.
It doesn't say.
Yeah.
So Rotten Tomatoes, all your statues.
Yeah.
Clouds parted.
Yeah, I didn't notice any cloud in the morning. It must have got up a little bit later.
More religious than I am said, it's got to be at least $10 in the poor box.
Yeah, right. Yeah, because it was just perfect weather when I got up and walked around, and everyone was like really wrapped, except for the two that were, I hope they enjoyed their book in the coffee shop, and I hope it got so dark that they thought that they'd gone blind or something. Yes. And there were, as I said, there were a number of people that booked the cruise, and we talked to some, and they knew nothing about the eclipse until the day before. Nothing whatsoever. They just booked the cruise.
Well, in the one in '76, there was the Victorian government actually said it was dangerous to even look at the sun. Maybe they still had those sort of hang-ups.
Yeah, yeah. I know, because that's the thing that you've always told not to look at the sun, particularly not with binoculars. But when it's total, you have to look at it with the naked eye or normal binoculars, or you won't see anything. Because if you've got these things on, it's totally dark.
People were even frightened of looking at lunar eclipses.
No, I know, yeah.
Somebody opened up their windows for them.
Yeah, apparently.
Yeah, this is radiation or something probably. Yeah. So anyway, hopefully we'll head off to this one on the Emerald next year. Just got to organise the flights, which is a bit difficult because you've got to get from Fort Lauderdale back to Melbourne, and if you want to do it on the day without staying in a hotel, it's about 36 hours to get home, and you have to go from Fort Lauderdale to San Francisco. No, Fort Lauderdale to Houston, to San Francisco, to Honolulu, to Sydney, to Melbourne. If you want to do it, book it as I just want to get on the plane and go home. Or you can just take a flight to Los Angeles, go to bed in a hotel, get up in the morning and get on the plane. And it costs you less to stay in the hotel overnight and then to try and get back ASAP. Yeah, because it's just all the connections. Because you don't want to book a flight at 10 o'clock in the morning when you get off a ship. And don't book anything before lunchtime, or you just won't make it. Yeah, yeah.
The airlines, the way they are, you really wouldn't want to book a couple of days before.
Yeah.
Cancel the flight.
Yeah, well that's the thing with getting over there. We can't get over there until the day before. So at the moment we're flying over the day before, stay in Los Angeles, right near the cruise port, and then the next morning we get up and we get on the ship. And then when we come home we've got a little bit more leeway, but at the start we've got no leeway. We've got like one day we come home from another cruise, we've got one day at home, and then we've got to repack and then fly to Los Angeles having just come back from Sydney. So we don't have the leeway. Yeah. Oh, it is. It's really tough. Yeah.
Trevor, amongst your dates, can you remember, or did you have anything about a partial eclipse in Melbourne for about 1960? I've got some vague recollections of something.
Right. No, I wouldn't remember that. I was only about that big. Yeah, no, I didn't look back any further than the 76 purely because I remember that. Anything before that, it's like, oh, I wouldn't know anyway. Yeah, the 1960s. You're talking primary school for me. I was in primary school.
I remember being out in the front yard with Mushy smugglers working on the car in the middle of the summer.
And it went dark.
Working on the car.
Yeah, I'll put my, oh, there it is.
Glasses.
Yeah, I don't want to leave them behind, that's for sure. Yes. I'll have to get new glasses one day. I got these just before I left Telstra in 2000.
Okay, sky for the month for May 2023. Year is getting along fairly quickly. During May, June, also do a bit of June as well because the next meeting's in mid-June. So we have a new moon on the 20th of the 5th, so 3 nights time. Not coming through on, oh it is okay. The full moon occurs just after the start of next month on the 4th of the 6th, so that'll be the next full moon. Things to look for, probably more the astrophotographers and those with big telescopes. The various comets, quite a few there at the moment. Comet P1, K1 Pan-STARRS, 1 degree east of IC International Catalogue 5052, which is a galaxy in Parvo. Anyone with a go-to scope will have an IC option, an NGC or an M option. So it's just a matter of putting in the right number and your scope will go to that target. So with 1 degree, it's about 2 thumb widths at your extended arm is about 1 degree. So fairly close to it. So if you find that actual galaxy, you should be able to see the comet around it. 364P Pan-STARRS. There's a whole heap of Pan-STARRS. Pan-STARRS actually refers to the organisation that is comet hunting. The other one is, or another one that seems to be fairly common at the moment, is ZTF. And that's in Cetus, which is the whale. I'll point these constellations out on the next page. Mercury reaches its maximum elongation west on the 29th of the 5th. So a little bit of warning for that one. Yeah, and it's supposed to be quite a good showing. The only downside, it's morning, AM. So hop up before dawn and you should be able to get a good look at Mercury. Comet Lemnon in Cetus there. Mars is fairly close to the Beehive cluster in Cancer. Now, Cancer's a very dull, not a very bright constellation at all. I think it's about the least brightest. You will pick it up. Mars is still visible, but it's a fair way away at the moment, so not really worth. Venus at greatest elongation east. Now, that's fairly obvious. If you go out there and you look out to the in the western sky now, you'll see a very bright object. That's Venus. And on the 4th of next month, it will be as far away from the sun as it gets. After that, it'll start going back towards the sun. And that's because it's orbit. Okay, and Comet Wild is in Ophiuchus. Ophiuchus is between Scorpio and Sagittarius. So the May sky, and you can see some of these things. So up here you've got Scorpius and Sagittarius down here, and I think Ophiuchus probably better, pretty close to it there, but sorry, there's Ophiuchus there. All right, the other ones that I mentioned, it might be on the next one. All right. Now, Chris did word me up that next month's MoPho is going to be globular clusters. Okay, so there's quite a few globular clusters. The 2 main ones to use, too close to it here. This one up here is Omega Centauri, which is the brightest cluster in the sky. And at the moment, it's in an ideal position to be viewed. It's as such, if you're in a dark enough spot, you can actually see it with the naked eye. It just looks like a bit of a fuzz, a very small star. Another one is 47 Tucana, which is down here, quite easy to find, but you'll need a reasonable southern view. So we can't really see it from here at the moment because of all those trees. That's another one. There's one up here right next to Antares in Scorpio. And M22 down here in Sagittarius. Now the downside of that too is Sagittarius is right where the centre of our galaxy is. Well, it's in that direction. And when you put a telescope on it, all you can see is stars. It's just for interest's sake, that's where Pluto is at the moment too, so good luck picking it out. Looking to the north, once again, what you've got here is what's known as the Virgo supercluster. It's part of the galaxy supercluster that our Milky Way is actually part of. So if you give our address, it would be the local group, which consists of Andromeda, the two Magellanic Clouds, and our own Milky Way, and one or two others. And then the next part of the address is the Virgo supercluster. So these are some of the closest galaxies to us. Galaxies are not the easiest thing to look at through a telescope, but certainly there's a lot of galaxies just in that patch there. M3 down here, globular cluster in Bootes. This is looking to the north, which for those who remember, you've actually got a much better northern perspective here, so long as you're not standing behind that tree there. Phil hasn't cut it down yet. What's going on? Don't cut it down. Yes, we'd be getting a please explain. Try and put a little steel rod or something so it attracts a lightning bolt. All right, so a couple of other star globular clusters. Once again, as I said, M4 up there in next to Antares. It's quite a busy little area around Antares there, and particularly for photographing things, Antares tends to dominate a little bit, being the brightest object there. Here's a red giant, so a nice big red star for you, but it has nebulas and it has the globular cluster there, so it's a bit of a tricky one to get. You also have M13, might be a little bit close to the horizon here, and certainly remember that's the direction Melbourne is. So when we look up there from the Briars now, you pretty well see the glow of Melbourne along the horizon. So a lot of these northern horizon things are not the most visible. So I would suggest if you those who are going to participate in MoPho, the two to look for are Omega Centauri and 47 Tucana. Now this is 10 p.m. On the May during May. What will actually happen is as the night progresses, that whole thing will turn about the south celestial pole there, which is just off from octans. So if you want to get up about 2 a.m, you probably get a good shot of 47 Tucana, because by that time it will have moved up to, try and get a see, up to about here. Okay, but as I said, Omega Centauri, it's the big one, and that's in a very good spot. So the planets, Mercury currently in the eastern dawn sky. By all accounts, it's actually fairly high, approaching its maximum elongation. So anyone who has a real hankering to see Mercury, maybe jump out of bed around about 6 a.m. when it's really cold, especially with the clear skies we've had lately. It was in inferior conjunction on the 2nd of the 5th, and then it reaches maximum elongation on the 29th. Now, remind you, Mercury takes 88 days to go around the Sun once. So it does it about 4 times in our year. All right, so it only takes 22 days to travel a quarter of its way through its orbit. That's why it appears so quick to go from a conjunction to an elongation in such a short period of time. On the 18th of the 5th, tomorrow morning, for those who are really keen and want to see something a little bit better, it'll be less than 4 degrees from the moon. And sitting right above it is Jupiter. So it should help you spotting Mercury. Not sure. I think Shirley was telling me earlier she got up and she couldn't quite see Mercury, but it might still be a little bit of twilight, or she might have been a little bit late, but it's right next to the moon, or 4 degrees from the moon, and Jupiter in the mixing pot there as well. Venus, no idea where Venus is. Big bright star out to the west at the moment. That's Venus. It reaches its maximum elongation next month. So for those who want to see it, now's your time to have a look. Although I always think Venus is a little bit better viewed, just as it's coming up, still in a slightly light blue sky, twilight sky, because when it's in a black sky, very, very bright, and very hard to get a telescope to focus on it nicely. For those interested, it's moving from Taurus into Gemini. You can always pick Gemini by Castor and Pollux, the twin stars there. They're quite obvious stars. Once you've seen them, you'll pick them just about every time. And as I said, you won't need the constellation to find them. Earth, nothing special happening on Earth at the moment. Some surprisingly clear nights, so obviously no PVN in the last week. So let's hope it stays that way for a little while. It does have a counter thing. It makes the mornings very cold. The outer planets, Mars has moved into Cancer. It's way down in the western sky now. It's a fair way away. It hasn't run from us. We've actually gone past it and kept going because we travel faster than it does. It's only about half the size of Earth, and the further it's getting away, even with a reasonable sized telescope now, you're not going to see much detail other than the fact it's red. Jupiter, Saturn, Uranus and Neptune. Well, Uranus has just come through conjunction, but Jupiter, Saturn, all those four big outer planets are all in a very similar part of the sky at the moment, which unfortunately is the AM sky. So Jupiter, another one very easy to spot because it's almost as bright as Venus. So when you get up in the morning, it'll be in the eastern sky. Okay, so all the morning objects you'll be looking over there, all the late evening objects you're looking over here. All right, it's just above the moon. This is tomorrow morning, just above the moon with Mercury next to it. So you've got the two planets, and the moon is only a sliver at the moment. So those who are really keen, want to get a photo, off you go. Saturn can be found in Aquarius, not that that helps. The good news there is it's rising about 1 AM now, so Saturn's not too far from coming back to a respectable time of the night for those of us who are a bit older in particular. On the 28th of the 5th, it'll be at a point known as its western quadrature, or quadrature. I keep calling it quadrature, it's quadrature, which basically means it forms a 90-degree angle from Earth to the Sun out to Saturn. What's so special about that? Big deal here. You get maximum shadow on the rings from the planet, which gives the whole planet, even through a telescope, quite a good 3D effect. And so it's certainly worth getting up and having a look just at Saturn. And Saturn will be fairly high at even say 2 AM, should be high enough for you to see if you're really keen. And that, but it is worth having a look at when it's at one. It also has an eastern quadrature when it's over the other side, and usually highlight the sky for the month. When you look at it, you can quite clearly see the ring of the planet's shadow on the ring behind it. So it really makes the globe of Saturn stand out. Uranus was in conjunction on the 10th of the 5th, so it's probably still behind the Sun, or effectively behind the Sun, so not currently visible. It should return to the early morning sky in June. Now, it's fairly featureless, even through a reasonable sized telescope. You're really only going to see a bluey-green disk. And the only one worse than that is Neptune. Early morning sky in Pisces. It's kind of between Saturn and Jupiter at the moment. They're all in that same part. And rises about 2 AM, so not far after Saturn. And even in a reasonable sized scope, it's still only a blue dot. So this is how they appear. Mercury on the 2nd went through inferior conjunction, so it's effectively a new Mercury to us. They tend to do a little bit similar to what the moon does. So why didn't we get a transit? Well, probably because it's above the ecliptic and we're below, or we're above the ecliptic too. It just depends. The planets have their time above and below. So we're really relying, to get a transit of Mercury or Venus for that matter, we really need the planet to be on the ecliptic and us on the ecliptic as it goes through inferior conjunction. And they're extremely rare events. Actually, I can't remember. The last Venus one was ages ago, early this century or something, I think. Yeah, there's a couple of pics there of it, but they're not all that common. Yeah. You got photos of it?
Yeah.
Have you?
Yeah.
You know, it's probably how long the last one was. How long ago? You're next oldest after Freddie, aren't you? Okay, Venus, as you can see, is quite large, and that's because it's coming towards us. And as it comes out of superior conjunction behind the Sun, it's travelling faster than Earth, so it catches it up, goes between us, and then heads into inferior conjunction and then pops up in the morning. So after superior conjunction, they become evening objects. After inferior conjunction, they become morning objects. So have a little think about why that is. All right, but in any case, it's travelling towards us, and as a result, we're starting to see a lot more of the shaded part of it, but the planet gets much bigger, so it doesn't really seem to diminish. Mars, as I said, you're not even going to see it that big. That's just from the projector there, but really that's about all you're going to see of Mars, is that it's red. All right. Saturn, what you'll notice with Saturn is those rings are getting awfully narrow, aren't they? 2 years ago they were quite wide open. Last year not too bad, but they're getting very close there. That's because we're going to go through the ring plane in 2 years' time, 2025. Now the ring plane, basically all the planets are like big gyroscopes. They all maintain the same angle going around the Sun all the time. And at 2 points in its orbit, where the Sun's there, Saturn gets to there, where its rings are edge onto the Sun, and as we go between it, we lose the rings. So that'll happen in 2025. So for those who are going to be here, that'll be worth having a look at, Saturn without its rings. All right, Jupiter, always large, always specky. Doesn't matter whether you look at it in the morning or in the evening. Full moons are usually quite clear, unless they're in front of it or behind it at the time. But just about each time you look at it, you'll see a different configuration. Uranus, as I said, not much more than a little greenish blue dot, but you can clearly see it through the telescope that it is a disk, so it's a planetary object. It doesn't twinkle like a star. And Neptune, I've got a 10-inch dob, and I've only ever seen it as a blue dot. I thought it was pretty good that I actually saw the blue. Okay, the other stuff. Comet V2 ZTF. This is not the green comet. As I said, ZTF is another group that seem to spend their time comet hunting. The green one was E3 ZTF. So there's a difference. Okay, E3 ZTF is buzzed off now. It's 13th, 14th magnitude, so good luck trying to find it. So V2 ZTF is in Aries at about 10th magnitude. Okay, and Pan-STARRS 1 currently in Parvo at about 11th magnitude. It's circumpolar, which basically means you've got the South Pole up there, South Celestial Pole. It'll whip round the pole. So basically, it rises just after sunset, and sorry, sets just after sunset, but then it pops up again just before sunrise, and it's just where we are in our orbit at the time. It will be at its highest in the dawn sky, which basically means it'll be above. If you imagine it going around the South Celestial Pole, it will be above the South Celestial Pole just before dawn, which would probably mean night time. It's a bit below the South Celestial Pole. Comet Wilds moved back into Ophiuchus, about 11th magnitude, rises in the evening southeastern sky. It rises, it's up in the northern part of the sky, which is where Ophiuchus is almost on the ecliptic plane. They're between Scorpio and Sagittarius. So not all that hard to spot that area. So you can have a bit of a go, try and find that one. And Comet Linear is in Aquila, around 11th magnitude, and rising in the eastern morning sky as well. So for the early birds, plenty to see. For those of us who don't like to get out until the temperature's in double figures, not much. And we had one meteor shower, which started on the 19th to the 4th. runs until the 28th of the 5th, so it hasn't got much longer to go. It did have its maximum earlier this month. However, the Eta Aquariids, which are associated with Halley's Comet. So it's the tail of Halley's Comet, and as we fly through it, we get particles from it. Upcoming events, I didn't know the 22nd one, so I do now. On Saturday, we've got the Working Bee starting at about 4 p.m, followed by barbecue. This is a good opportunity, if it's a clear night, for newer members in particular to bring their telescope. If you want to have a play with a telescope or learn how to use a telescope, this is probably a very good night to do it. The cloud gods heard me say that, so we know what's going to happen, don't we? Tonight's information provided by Astronomy 2023, Wallace Dawson, Northfield. Any questions? Oh, Phil, you getting as bad as Fred.
Look it up. You said Jupiter's going to rise early tomorrow morning.
Jupiter's already well up now of a morning. You get up just an hour before dawn. Jupiter's starting to get fairly high, so you can actually see Jupiter quite well. Tomorrow morning, you're going to have the moon, and within 4 degrees of the moon, you'll have Mercury as well. Yep. All right, and then Jupiter is above them. The reason for, well, it'll be out here. So you'll have the moon and you'll have Mercury coming up, and then Jupiter just above them. So, you know, if you really want to get up and have a look at it, you won't miss Jupiter. Jupiter's virtually a Venus in the east at the moment. So it's the brightest object there. Venus is the brightest one there. Jupiter's the brightest one there. They're the two brightest stars in the sky, if you like. So you'll have no problem picking it. But it's getting high enough now. Saturn's even ahead of it too, so you'll actually get Saturn as well. And Neptune, if you know exactly where to look. Have a play, try. Never know unless you have a go. Any other questions? Thank you.
Let's begin with the wedding cake of Queen Elizabeth II and Philip Mountbatten. Shown in the left-hand side there is my great-uncle, which is my grandfather's brother, Arthur Piercy, and he was one of the team that actually made the QE2 wedding cake. And as you see in all its glory there, it's 9 feet high and weighed 250 kilograms. And that was back in 1947. And down the bottom in the middle of the screen, you see a bit of that cake that was auctioned back in 2013. Someone had put it aside and hadn't eaten it. I think it sold for something like 2,000 British pounds at the time. I'm not sure if they actually ate it or whether they've stuck it in the freezer and are hoping to sell it for a bigger profit at a later date. Now, having been inspired by that, we thought we'd make something for tonight, coronation cake. So Ros kindly baked not a wedding cake, because wedding cakes for royalty are always fruit cake by tradition. She's actually baked Lord Harwood's treacle cake, as we call it in the family. It came into the Skilton family from the 6th Earl of Harwood back in the early years of the 1900s, when my mother was actually a child. It was passed to her, and then was passed down to my wife, who you see in the bottom left of the screen there, looking all very happy. Now, I did a Google search for King Charles coronation cake to see what it actually looked like, and strangely enough, couldn't actually find it. What it actually found was the one on the top right-hand side of the screen, showing a cake of 2 King Charles Cavalier Spaniels on it. So at the moment, I still don't know what the coronation cake of King Charles III looks like. And the closest I've ever come to King Charles Charles is about 2 metres. As he drove by me once when I was in university days, and he drove slowly up Swanson Street and waved at me. And how I know he waved at me was because I was the only one on that stretch of road on both sides. because it was all cordoned off by police, and they let me through because I had to walk through there to get up to university at the time. So he sort of waved out and waved with his other arm, not the one shown there. So what we'll do now is we'll go out the back and hopefully we'll cut a little bit of cake for you if you're interested in giving it a try of the secret recipe. I printed a little topper on the top of it, which is only a bit of paper, so you don't eat that. That basically says I wasn't invited either. On the top of the coronation cake. So enjoy something different for tonight to mark the occasion, given that it tends to be once in a lifetime or pretty much thereabouts. I'll start the remainder of the videos in about 5 minutes time, so feel free to either come back in or leave as you wish. Probably about 30 minutes worth before we close, so I'll only leave it at 5 minutes. So with that, go out, enjoy a cup of tea and hopefully a little bit of cake. And given the number here, you could probably have quite a good slab of cake. Absolutely. And for the benefit of those online, the cake is 9 feet tall and 250 kilos out the back.
Welcome to today's video on London Visited, and as you can see behind me, we are in Greenwich Park, which gives you amazing views over London once you reach the top. But today we're here for a different reason. We are going to climb to the top of the hill, and no, it's not a nursery rhyme. We're going to the Royal Observatory at Greenwich, to the home of time. This is part of the Royal Observatory, and I'm going to tell you all about this part and that red ball specifically, which can be seen from the Thames very shortly. This clock was installed in 1852 and is the earliest electronically driven clock. Always right to GMT, so in the summer it's out. It's a 24-hour clock because it's ever so slightly different, so noon's at the bottom and midnight's at the top. This is one of 3 sets of the official measures for imperial measurement. One's at Trafalgar Square, linked to the top here, one's at the Guildhall in central London, and this one here over at Greenwich. This official height measure from sea level at 154 feet is actually 46.93 metres if you like it in metric. Now, because the Royal Observatory is on the top of the hill, the view that you get over London from Greenwich is quite spectacular. So here we can see the Cutty Sark. We've already seen the City of London, and as we go across you can see the Thames just in front of the Royal Maritime Museum, which is right in front of us. Here you have Canary Wharf. The view you get from the top here is quite incredible, and I've put a link to another video that we've done for the views across Greenwich up in the top right hand corner. Here we're now looking out to East London and, of course, the world famous O2. All of this so far is without even going into the observatory, but as you do go in, you start to see sundials and other things related to the history of time. There's a number of different sundials and also different objects around the gardens before you even get into the observatory. We go from a sundial to a place where a telescope was kept, and that ring of bricks that you can see is all that remains of a 100-foot deep tunnel in which you can see here the telescope was enclosed in. With only that small space, can you imagine how small the stairs would have been to go down that 100 metres? So we go from a blocked up hole in the ground where a telescope was to part of an original telescope used by William Herschel. Something that I certainly learned is there are 4 different meridian lines, including the current GMT, and we're going to show you these, and this is the first one, which was Flamsteed's meridian line. Much like life is today, all the scientists sort of disagreed where the meridian line should be, but eventually they stuck with GMT, which you'll see a little bit later. Here we're in the Sun Garden, and yes, here we go. This is a sundial with a difference. You see this here? It's two dolphins, and where the dolphin's tail is and the sun shines on it, it actually tells you the time. As you can see, there are lots of guides to all of the different things that are here at the Royal Observatory, but sometimes you can just look and work it out for yourself. As the sun shines on this sundial, the sun goes through the two back ends of the fins where the dolphins almost meet. That then hits the plate that's underneath and tells you what the current time is. How great's that? Unfortunately for us today, the sun was very, very low, so it didn't hit. Right, let's go from a couple of dolphins to something else you're not going to want to miss, and it's here, the camera obscura. Let me tell you a bit about this. You're going to go into a dark room, and on this white table in front of you, you're going to watch the image which is coming through a camera which is at the top of this tower. What this does is it uses a lens in the top of the building to reflect the image that can be seen from that onto the table down below, as shown in this diagram. This is then reflected onto the table as a sort of natural projector, so you can watch what's going on live. And if you just look there, from the right tower to the left tower, there's boats going across the Thames. The brighter the day, the brighter the picture on the table. And also, that's why you've got a black curtain stopping any light from coming in. And if you look at the top of this tower underneath the ball, you can see the notch just there where the image is coming in. This is a popular thing to see, so make sure you get up here quick and join your place in the queue. But look at the views across from Greenwich, across the city, and there you can see St Paul's, close to the Sky Garden, which is the walkie-talkie shaped skyscraper, there on the right hand side. And then as you view across the city, you've got the Gherkin and the River Thames wonderfully in view as it comes into Greenwich. And there you can see the three masts of the Cutty Sark. So this is Meridian Line number 2. I promised you 4, 2 more to come. But this is GMT. This is what we use now, and this is known to be the Greenwich Meridian Prime Meridian Line. Here you can stand with one part of your body in the east and one part of your body in the west. It's incredible to think this block of concrete that you're going to see marks another GMT marker. As remember, there's 4 of them across, and this is number 3. It was later then found to be out, and it was then used to support a telescope. By the way, the arrow is just to point out it's not the bin or the bollard. This is another must-do. Just stand in the courtyard and take in the history that surrounds you as you look around the buildings here at Greenwich. Right, let me tell you about that red ball. What happens is, at 1 o'clock GMT, the ball actually rises and falls. So it is seen by those on the Thames, and those on the Thames know it is 1 o'clock GMT. Now, understandably, you're probably watching this video and thinking, wow, doesn't he know a lot? But look what you can do. There's loads of guides around, and you can also download the free app as well to get a free audio guide. Now, that doesn't happen often, does it? By the way, you can stick with your original thoughts. Yes, I do know a lot. Allegedly. So you'll notice it's only now that we're actually going into the observatory and seeing some of the scientific things used to discover GMT and also to look into space. It's incredible when you go around and you look at this and you go, that name rings a bell. Edmund Halley, of course, was famous for discovering Halley's Comet. And isn't it incredible? 18 years Halley spent here, but most of his research went down the toilet because he didn't check the calibration of his clocks and telescopes. Wow. Now, the incredible thing about the architecture here is when you look up, you can see that all of the roof opens up to expose the sky so they could use it to look through their telescopes. And not much has changed here over the last 100 or so years. If you're looking and thinking what those numbers on the wall for, they signify what number chapter you need to be on that free app that I showed you earlier. And here is Meridian Line number 4. What these 4 meridian lines show you is that all of the scientists and the astronomers got it all pretty close. Now, what I like here is that they've set the room up to look into space. Great, got the telescope, but look at the chair. They've even got a comfy chair. And once again, you can see as the roof hatches will open, will expose the evening sky so they can look out. Although looking at it now, not quite sure how comfortable that chair probably is. Right, we've moved from the Bradley Room and his meridian line to GMT, or the Prime Meridian as it's now known, and this telescope that's set up bang on 0 degrees. And once again, you can notice from the roof here that the hatches would be open so you could look out into the night sky. One of the great things about this place is how close you can get to all of the equipment and almost touch most of the stuff that's here, which is really, really good. And here with this telescope, believe it or not, they used to climb down into this pit and look up into space from down there. Now on the roofs you will have noticed some domes, and these are observation areas where telescopes were used. Here is one of the first ones, and this is particularly good because you've got all sorts of time phrases. Which one's your favourite? Let us know in the comments down below. I think the only one that's missing is from the James Bond film. We have all the time in the world. But do we? I suppose that's the question. And it's incredible to think that this dome was used with telescopes to look and measure the moon, the stars, and find all sorts of things well out into space for about 120 years. Now here, in this part of the exhibition, you have all sorts of timepieces, clocks, etc., which are available on show, which shows you a history of time. Now, once you've finished this part of the exhibition, you take the spiral staircase up to the Great Equatorial Telescope. What's that? It's the biggest telescope that they have here at the Royal Observatory. And look at this. This telescope has been used to discover all sorts of things happening on different planets and in different stars across our solar system. So just think of the history that's been viewed down this telescope. Now, one of the things that they do offer here is during some of the winter nights, you can come in, obviously you pay for it, but you can come in and you can look into space with the telescope. So if you're a real star buff and you like space, it might be something worth considering.
Throughout the history of human spaceflight, there's always been this balance between ambition and crew safety. And this has meant there have been many different approaches to crew escape systems over the years. And I can think of a handful of historic spacecraft which were equipped with ejection seats. And I actually want to talk about these very specifically. You see, since ejection seats were already developed for military planes, it actually made a lot of sense that the technology would also be used in space programs which inevitably would have strong links to the military. So ejection seats logically compete with launch abort systems that pull the whole capsule clear of a failing booster. But they actually have an advantage in that they can also provide an escape option on descent if there's any failure in the spacecraft that would result in a dangerous landing. Now, the first man to fly in space, of course, and indeed the first dogs to return from space safely, they flew on a spacecraft with an ejection system. The Soviet spacecraft would all return onto land, unlike the US approach of splashing down the capsules in the oceans, which would make the landing softer. So it was standard procedure on Vostok to use an ejection seat during the landing, because landing the capsule on the ground was considered too violent and hazardous for the occupants. But the same seat was also intended to be used in launch abort scenarios if there was a problem with the booster. Now, at the time when they were building the Vostok out, the engineering complexity of a launch abort system and a soft landing system for the capsule was probably beyond what the program was able to do, and so it favoured developing just an ejection seat that would suffice for both. The seat plus the crew member and their pressure suit would account for about 7% of the mass of Vostok. That's about 170-180 kilograms. Inside the capsule, the seat was oriented at a 65-degree angle, so if it was fired on the ground, it would ascend at an angle of about 25 degrees, giving them just enough altitude and time to deploy the recovery chute. Deployment would use pyrotechnics to eject the hatch on the side of the Vostok capsule, and there was a cutout in the fairing for the hatch. Then a pair of solid rocket motors would drive the seat up the rails, clear of the capsule for a few seconds of accelerated flight. The capsule deployment would be accelerated by a gun-propelled system so that it would fully inflate the canopy at the low altitudes, separate the occupant from the seat, and then allow a safe landing. Now at this point, we should consider the chain net that is there to catch a person. If you look at the Vostok launch pad, it's constructed around a huge pit into which the rockets would fire, but in the event of a pad emergency, it was possible that if a booster was leaking propellant, that would form a pool of burning liquid, and it would be unfortunate if the cosmonaut would eject from the rocket and then land in a pool of burning liquid, hence the giant net next to the rocket. So the seat was used for all the Vostok missions. During the landing, the seat would deploy at around 20,000 feet and the crew member would parachute down. So there's a story about Yuri Gagarin parachuting into the middle of a field in a spacesuit and asking incredulous farmers where he can find a telephone before the local military got there and they had been alerted to this possibility. Initially, the fact that Yuri ejected from the capsule was kept quiet as the Soviet Union didn't want to have their rocket achievements dismissed by record keepers on some technicality of not landing in the spacecraft that the crew launched in. I'm sure at this point we all know Gagarin's place in history, regardless of what the rules at the time said. Now, a similar ejection system was also used for the Vostok tests that would carry dogs, including the first orbital flight with Bella and Strelka. However, the launch prior to Bella and Strelka was a failure, and at the time there was no way to trigger the ejection sequence during the launch. So the capsule fell off the rocket as it broke up, and it just landed without a parachute, killing the dogs inside. But later, the same ejection system would also fail during another launch abort, and it would actually be a good thing this time. The booster failed late in the flight, and the capsule ended up landing in deep snow in Siberia. The temperatures were like -20 Celsius. So the ejection system malfunctioned and the dogs, Comet and Shutka, remained inside the capsule. And that actually kept them warm enough for the 2 days that it took to find the capsule and recover them. So that was something of a miracle. And by the way, I think it happened on Christmas Day. Anyway, the Voshchod spacecraft was derived from Vostok. It included rocket motors to soften the landing now, but it had no launch escape system, so a problem close to the ground would have been fatal for the crew. At around the same time, the US was beginning to fly astronauts in Germany, and they had switched over from the escape tower of the Mercury spacecraft to using a pair of ejection seats for the crew. One reason behind this was that the engineers argued that a hypergolic propellant used on Germany's Titan booster would burn as it mixed, rather than mixing up to an explosive mixture and then detonating. Therefore, a catastrophic booster failure was thought to be less violent, more like a fireball rather than a detonation. The Gemini seats were developed specifically for the vehicle. During launch, they would only be useful for the first 75 seconds of flight. After that, the abort mode would have the entire capsule separating by firing all 8 of the retro rockets simultaneously rather than staggering them as they would in a deorbit scenario. So upon activation of the seat, pyrotechnics would disconnect the latches and push open the hatches in about a quarter of a second. The catapult segment would push the seat up the rails in about 0.16 seconds. The catapult works by igniting a hot gas generator charge inside a piston, and that pushes the seat up without firing an actual rocket in the cabin. It was designed so that when it reaches maximum extension, the hot gas is now allowed to flow into the rocket motor, and that ignites the motor. So then the rocket motor would fire for another quarter second with almost 4 tons of thrust. So if we do the math on this, the occupied seat mass was 375 pounds. The thrust was 8,300 pounds, so the acceleration is about 22 g. And in a quarter of a second, that would be moving about 56 meters per second or 200 kilometers per hour. This was apparently the most powerful rocket catapult ever developed by the US. So after the motor stopped, the restraints would be cut and the pilot would be ejected from the seat about 1.5 seconds after the start of the process. Next, a balloon would be deployed. That's a small balloon parachute, which would be robust enough to survive at supersonic speeds. At high altitudes, this would be used to stabilize the free fall until the occupant descended below 7,500 feet and the balloon was released. Then the regular parachute would deploy at 5,700 feet. Now, if the seat was activated below this altitude, the balloon release would happen and the balloon would be deployed and immediately be released. And about 3 seconds after initiation, the drogue gun would deploy the parachute and the full canopy would be deployed at about 5.8 seconds. So that's 5.8 seconds from pulling this to being under a parachute. This is rapid enough that they could operate this safely from the pad. Now, to get the seat ready, there was years of testing. There was like a whole bunch of early tests that I looked at, and they sound like scenarios from a Wile E. Coyote scene with all sorts of weird failures. It was also tested in flight at supersonic speeds on an F-106B Delta Dart at Mach 1.75 and 40,000 feet. The Delta Dart was one of the fastest planes available. Indeed, at the start of the 60s, I think it held the speed record for a jet plane. An often overlooked but important part of the system was the restraint lines, which would pull the astronauts' arms and feet into the correct location, ensuring that not only that they didn't get hurt by flailing limbs, but it would also keep the center of the mass of the seat close to where it was supposed to be, so that it wouldn't spin when the rocket fired off center. Apparently, they would actually tune the seats for the specific occupants by adding lead weights as ballast. Later on, as the Air Force developed the Blue Gemini and the Manned Orbiting Laboratory, they considered replacing the ejection seats because the Titan rocket would now include a pair of large solid rocket motors. This would change the hazards, but in the end, none of this ended up happening, so it was a kind of a moot point. So now, moving on a decade or so, the early test flights of the space shuttle included ejection seats. Firstly on Enterprise for the unpowered gliding tests, and later on for the first 4 test flights of the Columbia. Unlike Gemini, they didn't develop a custom seat for this. They instead used a seat which had previously been developed for the SR-71 Blackbird, the aircraft that many people describe as the king of high altitude, high speed, long endurance flights, if they've never heard of the A-12. So the ejection seat in the SR-71 actually began life on the F-104, and indeed some of the early SR-71s and A-12s still have the C2 ejection seat from those F-104s. The main differences were that they changed the headrest around and the restraint system to hold the occupant in place to accommodate for the greater forces. There was an incident early on where a breakup resulted in the fatality of one of the crew members because he broke his neck because the headrest didn't hold his head in place. Now, unlike their more mundane counterparts on the fastest jet planes ever made, the seats on the shuttle were adjustable so that the crew could reach the important controls while the shuttle was vertical on the pad during those long launch attempts that went nowhere. Sound familiar? Unlike the seats on Vostok or Gemini, they were no good on the pad. The angle of the launch rails wouldn't give the seats any altitude. So the seats weren't a viable escape option until about 10 seconds into flight once the shuttle had got enough altitude. And from that point, they were only good until about 80,000 feet, which is lower than the usable altitude on the SR-71 or the U-2. The reason was, at this altitude and airspeed, the aerothermodynamic heating would melt the faceplates of the helmets, which would make a bad day worse. On the early days, in the early flights, you can actually hear a call out for negative seats once they reach this point. But they did offer some emergency options that would otherwise have been lacking, especially early on in the program when they were testing whether the shuttle could actually fly like an aircraft because with its aerodynamics that were really optimized for not burning up during re-entry, and a massively complex computer-controlled fly-by-wire system that could leave the crew without any way to control the flight if it failed during operation. The shuttle had to include panels for the crew cabin and the forward fuselage, which would have to be ejected prior to the seats being able to operate. The launch rails in the cockpit ran from the floor all the way up to the ceiling, braced so that they could sustain the forces of the launch of these seats. The seats were only available on the first 4 shuttle launches. After that, the shuttle was declared operational, and from that point on, it would carry more than a crew of 2. On the 5th flight, the seats were still installed, but they were disabled because they would only work for the pilot and the commander, and the 2 people in the back would be out of luck. So for ethical reasons, they weren't available. The fuselage of the shuttle would need to be modified if they wanted to accommodate the 2 crew in the back. But for the crew in the mid-deck, it was difficult to see how you could accommodate them with ejection seats. It wasn't a realistic solution. So Columbia would fly 1 more flight after that with the seats installed, again inactive, and then the orbiter was sent back to the factory for overhauling and the seats were removed. No other shuttle orbiters would fly with the seats. Now, there was one other spacecraft which flew with ejection seats, and they're the seats that were designed for the most extreme speeds, far beyond the operational envelope of any of the others I've described. The X-15 experimental hypersonic research vehicle, it flew to space on a handful of occasions, but more importantly, it regularly flew at hypersonic speeds, and bailing out at these speeds would expose the pilot to high dynamic pressures, stresses, aerothermal heating. This was bad news. Previous X-planes had actually used entire escape capsules where the cockpit would break away and slow down enough under a parachute, enough to let the pilot bail out on his own. But having a capsule added a lot of mass and complexity, and the X-15 was looking for the maximum performance possible. Scott Crossfield studied the pros and cons of seats versus capsules, and he concluded that a seat would work almost as well as a capsule while saving tons of mass. So the seat was intended to work at speeds of up to Mach 4 and altitudes of 120,000 feet. Now at those speeds, the temperature of the airflow as it hits the person is about 600 Celsius, and that would very quickly burn an unprotected body, even a body wearing like a pressure suit. So the seat actually included shields, deflection panels that would push the airflow around sensitive regions to minimize the heat flux the occupant would receive. In particular, the hands and feet and head were regions that could experience extreme heat and they would have protection. But the thing which really set the seat apart from others is its aerodynamics. Most seats would separate the seat and the occupant moments after separation so that they could get on their parachute. But doing so at hypersonic speeds would probably kill the occupant due to the aerodynamic forces on the body. So the seat was designed to keep the occupant in the seat, holding them restrained to avoid injury. Furthermore, it had to be designed so that it wouldn't spin up and make separation later more dangerous. So the seat would deploy like fins and a pair of extending booms which would stick out the back, and this would ensure the center of drag was aft of the center of mass, so the seat would naturally stabilize into a forward orientation straight after ejection. And that allowed it to slow down and get to lower altitudes where they could deploy the parachute. So seat separation is delayed by aneroid barometers until they reach an altitude of 15,000 feet. Or if they were below this altitude, there would be a fixed 3-second delay. But if you were below 15,000 feet, it was expected that the aircraft would be much slower and therefore the ejection would be survivable at these low altitudes. So yeah, I think the X-15 ejection system probably qualifies as the most extreme ejection system ever, and actually probably one of the most extreme parts of the X-15, which is definitely high up there in the use of the term extreme. I'm Scott Manley. Fly safe.
An aurora is one of nature's most spectacular visual phenomena, bright lights dancing across the night sky. The brightest auroras are concentrated in rings called the aurora ovals around the north or south poles. The auroras in the northern hemisphere are called aurora borealis. The southern lights are called aurora australis. Australis comes from the Latin word for southern. Auroras are the result of events that begin on the sun millions of kilometers away from the Earth. The sun is so hot that high-energy plasma electrons and protons can escape from the sun's gravitational field, and this is what's called the solar wind. When the sun is relatively inactive, the solar wind travels at about 300 to 400 kilometers per second. When the sun is more active, eruptions can occur which release dense plasma or plasma clouds into the solar wind. These plasma clouds carry magnetic field structure from the sun to the earth at speeds up to 2,000 kilometers per second, and that's what we call a solar storm. The solar wind has enough energy that it could strip away the Earth's atmosphere over time. However, we're lucky. We have the Earth's magnetic field, which is caused by hot, electrically charged molten rock, which is swirling around in the outer core of the Earth. The interaction of the solar wind with this magnetic field creates a protective cavity called the magnetosphere, which deflects most of the particles from the solar wind. However, during a solar storm, the fast-flowing plasma temporarily deforms the magnetosphere, causing a buildup of energy on the night side of the Earth. When conditions are right, this energy is released, accelerating charged particles so they spiral around the magnetic field lines towards the North and South Pole. When these particles reach the upper atmosphere, they collide with neutral atoms of oxygen and nitrogen. And during these collisions, the charged particles transfer energy to the atoms, exciting the electrons to higher energy levels. When the electrons return to their original energy level, the atoms release this energy in the form of light, and at various different wavelengths, and the wavelengths determine the color of the light. Which color is emitted, that depends on how energetic the collisions are and where they occur in the atmosphere. Oxygen releases greenish yellow or red light, nitrogen dark red or blue light. And then these colors can mix so that we see purples, pinks, and white light, and that's what makes these beautiful lights. You do have to be pretty lucky to see an aurora, but if you do see one, you won't be disappointed. The brightest auroras are concentrated in rings called the aurora ovals around the north or south poles. The auroras in the northern hemisphere are called aurora borealis. The southern lights are called aurora australis. Australis comes from the Latin word for southern. They're best viewed from Antarctica, Tasmania, and the southern mainland coastlines. The colors displayed by an aurora are generally visible to the naked eye if you're near the poles. This is because the aurora is overhead and more intense. However, at lower latitudes, the auroras are on the horizon. Less color is seen by the naked eye. The lights tend to be shades of gray. However, if there is a high intense solar storm, there will be more color. Auroras can occur at any time in the year, but they're most likely to occur during the months of March and September. That's when the Earth's magnetic field is best oriented to interact with the solar wind. Of course, you ideally need a dark night with little cloud cover. You don't want a bright moon or any light pollution. So a good location is a dark beach or a hill where you have an unobstructed view to the south. Bright auroras usually last for 1 to 3 hours. And the best viewing time is around midnight between 10 p.m. and 2 a.m. When we forecast solar wind conditions that look favorable for auroras occurring in the next 1 to 3 days, the forecasters from the Bureau's Space Weather Center issue what's called an aurora watch notice. When there's a high chance that there will be an aurora visible now, we issue an aurora alert. To be truthful, nothing beats seeing an aurora with the naked eye.
string theory right? Is it just fantasy? Caught in the landscape, out of touch with reality. Compactified on S5 or T-star S3. Space is a pure void. Why should it be stringy? 'Cause it's quantum, not classical, non-renormalizable. Any way you quantize, you encounter infinity. You see. Quanta must interact via paths we understand, using Feynman diagrams. Often they will just rebound, but now and then they go another way. A quantum loop. Infinities will make you cry unless you can renormalize your model of baryons, fermions, and all other states of matter. Curved space, the graviton, can be thought of as a field, but these infinities are real. In a many-body loop diagram, our results diverge no matter what we do. A quantum soup. Kiss your fields goodbye. Guess Einstein's theory wasn't complete at all. I see extended 1D objects with no mass. What's their use? What's their use? Do they give us quark plasma? Can we minimize one function that describes this state?
Nambu Goto, how to quantize, I don't know.
I'm just a world sheet, please minimize me.
Here's just a world sheet from a string theory. Re-parameterized by a vital symmetry.
Fermi bows, open, closed, orientable.
Vibrations. Balls, they become particles. Vibrations, they become particles. Vibrations, they become particles. Become particles. Become particles.
Oh, mamma mia, mamma mia.
Such a sum of particles. A tachyon, a dilaton, and gravity.
So we need 10 dimensions, and I'll tell you why.
Insulation.
So to get down to 4D, we compactify. Oh, Caleb. Manifold must be Caleb. If we want to preserve any of us above symmetry.
So the strings I took 1 to A and 2 B. Heterotic O and heterotic E. Over 1 through S and T duality. Thank you, MIT, for that superstring revolution and your new M theory.
Super
That's some pretty heavy string theory mathematics are there, but nevertheless a very well put together thing. And with that, we'll officially close the May meeting until next time.